Hello. In this problem, we are given some properties at the inlet state of the turbine. We really don't have to know what a turbine is in this problem. Anyway, it produces shaft work as a flow of steam goes through it. And we are asked to find several transport properties, J dot, H dot, K dot, etc. at the inlet state, which is the state 1. So let's start, and we're going to use the PC flow state test calc. So let's start and log into thermofluids.net. Again, the test calcs work only for Firefox, and there has to be Java downloaded. And this particular icon tells you exactly how. There's a little video shows how you tune your Firefox to include Java. So let's launch the test calcs. We go to the test calcs tab, and we are going to evaluate a flow state at the inlet of the turbine, and the model we are going to use is the PC model, which is the phase change model. When there is liquid to vapor transformation possible in a problem, we use the PC model. And the first tab is the PC TESTcalc tab. Click run, and here we go. The H2O is already the default fluid, so we have a steam turbine. Steam means H2O. So what are known? Pressure, we basically enter whatever is known. Pressure is known to be 2 million pascal at the inlet. Temperature is given as 500 degrees Celsius. That's already the default unit. Mass flow rate is given, m dot, to be 10 kg per second, and the area is given as 0. Well, we cannot enter the area, notice, because the velocity already is specified to be 0. So let's reset it. So there is no velocity, is now an unknown. Notice the elevation is set as 0, which is a good assumption always. The variation of elevation really doesn't change anything in case of a steam turbine. So the area is given. Look, now the area can be entered because velocity has been made an unknown. So the area is given as 0.2 meter per second. Is that area is given as 0.2 meter per second. 0.2 meter square. So we enter the area here, 0.2, and we calculate our state. So all the properties, a lot of properties, including, notice the velocity has been found. And the question is, find different kind of transport properties. So we can go to the I/O panel, and I just want to show you how to use the I/O panel to calculate those quantities. So what is the flow rate, the rate of transport of flow energy? It will be simply m dot 1 star J1. That has been found. So what will be, for instance, rate of flow of H dot? H dot is what? Enthalpy, m dot 1 star H1. So this is the enthalpy being carried. Notice how close is the rate of flow of enthalpy and rate of flow of kinetic energy, flow energy. That's because if you find the rate of transport of kinetic energy, which is m dot 1 star velocity, VEL1, velocity square divided by 2000 to get that in kilowatts. Notice how small is the kinetic energy being carried by the flow. So the enthalpy is the bulk of energy. If you recall, enthalpy, the flow energy J is given by H plus KE plus PE. So J dot, which is m dot times J, equals m dot times H, m dot times KE, m dot times PE, right? And this is nothing but H dot, this is nothing but KE dot, and this is PE dot. So as you can see, if the Ke dot is so small, and we assume Pe dot to be 0, anyway it will be very close to 0, then J dot and H dot are almost equal. So going back to the TESTcalc, you can calculate all the other transport properties. Let's just take a moment here to illustrate, to tell you some of the other, for instance, features of TESTcalc. You can draw the state, say in a TS diagram, temperature versus entropy diagram. This involves a lot of advanced concept, but you can draw a constant pressure line, and so the inlet state of the turbine is shown here at state 1. There are many other features of TESTcalc that will gradually become clear. One of them is, if you click on the super calculate button, what it does, it recalculates everything and produces a detailed output on this screen, on the I/O panel, on this panel. And not all the properties, even the tables of properties, are produced here. When you have many states calculated in a given problem, you will find that what is given is separated from what is calculated state after state after state. Moreover, there is something called test code that is produced by supercalculate. If this little bunch of script, if you copy and save it in a word processor later on, you can come here, and in the I/O panel you can paste it back, and by clicking this load button you can regenerate the solution. We'll discuss these advanced concepts of TESTcalc that you can use to solve and verify very complicated problems in the chapters to come. So I'll stop here and let you experiment with the TESTcalc.